All right, guys, we're going to go on and get started going over the review sheet. Yep, I know. So, let's look at problems 1 through 3. Are there any questions on problems 1, 2, or 3 on how to do any of these here? So we look at number 3. We wanted to state the degree and leading coefficient. So what is the degree of this polynomial function? So the degree for this here would be 7 because x to the 7th is the variable with the biggest exponent. So the degree is 7. And the leading coefficient would be negative 27 because the leading coefficient is the number in front of the variable with the biggest exponent. So the variable with the biggest exponent would give us the degree because it would be that exponent, and the number in front of it is the leading coefficient. Any other questions on 1, 2, or 3? All right. Let's look at questions 4 through 7. Is there a question on problems 4, 5, 6, or 7, or one of those that we want to look at? 7. So we look at problem number 7. We want to evaluate this function when x is negative 12. So what we're wanting to do is plug in negative 12 for every x. So every place where there's an x, we're wanting to plug in negative 12 for it. And now we can evaluate it. We want to simplify it down. Now we can do this by hand or we can do this in the calculator. So if we do this in the calculator, we can type it in replacing every x with negative 12 in parentheses. So we can say 5 parentheses, negative 12, close parentheses, to the third, minus 3 parentheses, negative 12 squared, plus 2 times negative 12 plus 4. And when we get the whole thing typed in, we'll go on and hit enter, and it'll tell us that the answer is 9,092. And that would be our answer. Now the other way that we can do this is we can store it into a variable. And to store it in, we can type in the number first, so negative 12, store x. Store that number in for x. We hit enter, it'll tell us negative 12. At this point here, we can type the equation in, 5x to the third minus 3x squared plus 2x plus 4, and hit enter, and it'll give us the exact same number. So either way, we could either plug in the number inside parentheses into the calculator or input it in for x. Either way works. Any questions on number 7? Any other questions on problems 1 through 6? 1 through 7? All right, let's look at problems 8 through 10. All right, so looking at problems 8, 9, or 10, are there any questions? Well, let's just go on and look at these here. Looking at problem number 8, determine if the following function is a polynomial. Is number 8 going to be a polynomial function?
Do you have any extra?
No.
Because of the negative exponent. Because, yep, if the variable has a negative exponent, it will not be a polynomial function. How about number 9? Yes. Because when we look at this here, there are no variables in an exponent. We also have no negative exponents attached to a variable. We have no fractional exponents attached to a variable. No variables in the bottom of a fraction. No two variables are being multiplied together. And no variables inside of a radical. So it satisfies all of those. It is a polynomial function. How about number 10?
No.
Because of
The half.
the half, x to the 1/2. We have a fractional exponent attached to a variable. Going over the review. Any other questions on 8, 9, or 10?
Oh wait. Which ones are the not polynomials?
So I do have it listed up there. I will post that later tonight. Let's look at 11, 12, and 13. Which one of those do we want to look at? Okay. 12. So when we look at 12, we're adding these two together. Now with addition, we don't have to worry about sign changes. We can just add the like elements. So we start off with 12x to the 5th because x to the 5th, there are no like terms with x to the 5th. Now the next one we can look at is x to the 4th, and well, we have negative 3x to the 4th and 8x to the 4th. We can add those together. Plus 5x to the 4th. Now we can go to cube. We do have an x cubed, but we only have one of them. So we'd have negative 3x cubed. Do we have any x squared? No, so we won't include it. And we can move on to x. Yep. 2x plus 4x is plus 6x minus 4 is negative 5 plus 1 would be our minus 4. And that there would be our answer. Let's look at number 14 for our subtraction. Now, one thing we do have to remember is everything in the second set of parentheses is going to have a sign change. Because when we have the negative out front, it's going to apply everything inside the parentheses. If you have trouble remembering that or doing that, that's fine. We can do it vertically. If we write this out vertically, I'm just going to rewrite the first set of parentheses first. If there's a variable missing, I'm going to leave a gap. So our first one is 11x to the 4th. Do we have an x cubed term in the first set of parentheses? No, so I'm going to move over, leave a gap. And we do have our x squared, 3x plus 11. So I left a gap at where x cubed should be so that we do have a space so it doesn't match up to anything else. Now in our second set of parentheses, we do have our 2x to the 4th plus 6x cubed. But we don't have an x squared term, so I'm not going to put anything under the negative 9x. Plus 2x minus 9. And at this point, we're going to subtract. Exactly as Trey said, 11x to the 4th minus 2x to the 4th is 9x to the 4th. Now, we don't have an x cubed term here, but we are minusing 6x cubed, so this would be negative 6x cubed. Negative 9x squared minus, well, we don't have anything here, so it's just going to be negative 9x squared. 3x minus 2x is going to be plus 1x. And 11 minus negative 9.
If you wanted to, could you put 1x?
Yeah, you can put 1x, that's fine. When we get this here. So this right here would be the correct answer. Any questions on this here? What are you ready for the next set? Questions on 15, 16, or 17? 15, 16, or 17? Kind of. 18 and 19 aren't going to show up on the test, not because they're not going to be tested, it's just tedious and time consuming. It is just going to be multiplication. 18 and 19, no. So 16, we're just doing our multiplication. So we're going to distribute the 2x through. So we're going to do 2x times 2x squared, 4x cubed. 2x times 5x is going to be plus 10x squared. 2x times 8 is going to be plus 16x. Then we would do the same thing with 4. 4 times 2x squared is going to be plus 8x squared. Now you can put it all in one row or you can line up the like terms. Either way works just fine. Now 4 times 5x is going to be plus 10x, and 4 times 8 is going to be plus 32. Now once we finish multiplying and distributing all the way through, we can add our like terms. Well, 4x cubed doesn't have any other like terms, so we have 4x cubed. Our 10x squared and 8x squared are like terms, plus 18x squared. Then we have 16x and 10x, which is plus x plus 32. And that would be it. Any other questions on 15, 16, or 17? Question? In that closet, down, go in there. Light switch is on the other side. Other side, behind you. Down and on your left. All right, guys, let's look at 20, 21, or 22. Is there one of those that we want to look at? Let's look at 22. Now for these here, we can divide using synthetic or long division. I have a feeling y'all like synthetic better than long division. Okay, so I'm going to show you guys doing this one with synthetic division. So to set up synthetic division, we make the cubby hole and the line. And we solve x minus 1 and set it equal to 0. We solve for the value of x. So the first thing that we do is we're going to add 1 to both sides, which tells us x is equal to 1. And we put the 1 in the cubby hole. From here, we put the coefficients, the numbers in front of the variables on top, and if any variable is missing, we put in a 0. Now we would have 7 for x to the 4th, negative 10 for x cubed, 3 for x squared, 3 for x and negative 3, and we will bring down the 7. And now we're going to multiply. So 1 times 7 gives us 7. Negative 10 plus 7 is negative 3. 1 times negative 3 is negative 3. 3 plus negative 3 is 0. 1 times 0 is 3 plus 0 is 1 times 3 is, and negative 3 plus 3 is. So the 0 would be the remainder. 3 would be our constant term. 0 would be the term with x. 3 would be the term with x squared, and 7 would be the term with x cubed. So that gives us 7x cubed minus 3x squared plus 3. Because any of the terms that are 0, we don't have to rewrite them back in. We can just leave them out. No, we can. Okay. So 21 with synthetic or long division? Okay, because the one we just did was synthetic division.
So this one, like, in the cubby hole, it would be positive 7, right?
It would be positive 7. Because we would take x minus 7 and set it equal to 0.
Plus 7.
Add 7 to both sides, which will tell us that x is equal to 7. So going across the top, we would have 1 for x to the third, negative 13 for x squared, 40 for x, and 18 for our constant term. Then we would bring down the 1.
Why did it all shift over?
What do you mean?
Never mind. You just kind of wrote it off to the other side.
Yeah, I wrote the equals to the other side. Now we do our multiplication, so 7 times 1 is?
7.
Add straight down. Negative 13 plus 7 is? Negative 6. Then we would multiply again. 7 times negative 6 would be? Negative 42. Add straight down. 40 plus negative 42 is? Negative 2. And 7 times negative 2 is? Negative 14. And 18 plus negative 14 is 4. Now 4 will be our main. Negative 2 will be the constant. Negative 6 is the term with x, and 1 is the term with x squared. So what we're left with is x squared minus 6x minus 2 plus 4 over what we were dividing by. And what are we dividing by?
7.
X minus 7. And we have this here.
Makes it straight. Oh, I just got a banging headache.
Because 20, 21, and 22 can all be done with synthetic division just fine. If we have time at the end. Let's look at 25 and 26. Because the two that we skipped work better with long division than synthetic. Find all the rational zeros are plus or minus p over q. Do we want to look at 25 or 26? Which one? Okay. So when we write this here, our p and q, p is the factors of the constant term and q is the factors of the leading coefficient. So our constant term in this case here is 15. Now the factors of 15 are 1 and 15 and 3 and 5. So 1, 3, and 5 are the factors of 15. Now the leading coefficient is 12. So our factors of 12 are 1 and 12, Now what we can do here is we can start off with the first value of q and divide every p by it. Well, our first number is 1. So realistically, we're just going to end up listing out all of the values of p again. Because anything divided by 1 is just going to give us what we started with. We're going to leave it in fractional form. This is the one time I do not want decimals. We're going to leave it in fractional form. Okay? Because the next one that we're going to look at is 2. So we're going to have plus or minus. Well, the first number is 1 divided by 2. Our next number would be 3 divided by 2, which doesn't reduce. So we have 3 halves. And we would do 5 next, which would be plus or minus 5 halves, and then plus or minus 15 halves. Well, we know that this won't reduce because 1, 3, 5, and 15 are not even. They're not even numbers, so they won't reduce. So we get this here. Any questions on this so far? Well, the next number we're going to look at is 3. So we're going to have plus or minus 1/3, because 1 is always going to be included, because 1 divided by every q will be listed because we can't simplify it any further. So we'll have 1/3. Our next one is going to be 3 divided by 3, which is 1, which we already have, so we don't need it. 5/3, well, it won't reduce, so we'll have plus or minus 5/3. And then the last one would be 15 divided by 3, which is 5. We already have it, which means we can move on to 4. Well, 1, 3, 5, and 15, will any of these divide by 4? No, they won't simplify at all, so we're going to list them all back out. So we'll have plus or minus 1/4, plus or minus 3/4, plus or minus 4ths, and plus or minus 15/4. Any questions on this so far? Now we're going to repeat this process with 6. So we'll have plus or minus 1/6. Now the next one would be 3/6, which reduces to 1/2, and we already have it. Then the next one would be 5/6. Will that reduce? Well, no, so we'll have 5/6. And then the next one would be 15/6. And it will reduce because they both have a common factor of 3, which would be 5 halves, which we do have. And lastly, we have 12. So we will have plus or minus 1/12. Then the next one would be 3/12, which would reduce to 1/4. We already have 1/4. And then we would need 5/12. And 15/12 would reduce to 5/4, because they both have a common factor of 3. And now that we've gone through all the values of q, this here would be our answer. Not that long. Yeah.
Not that hard, it's just
Mm-hmm. Just takes a while to write.
you to do our test?
I think it was somewhere around 8 minutes. Any other questions on this one here?
Done before the 8 minutes. There's something written on every question you have me.
If they're all right. 27 or 28, which one do we want to look at? So this here is Descartes' rule of signs. We want to find out the number of possible positive, negative, and complex solutions and their combinations. To find the number of possible positives, what we do is we take the function itself, f of x, and count the number of sign changes from one term to the next. So from x to the fifth to x to the fourth, it goes from positive to negative, so that would be one sign change. X to the fourth to x third would be 2, because it's going from negative to positive. X cubed to x squared would be 3, because it's going from positive to negative. Now x squared to x would not be 1, because it's going from negative to negative. It does not change signs. And negative x to plus 40 would be 4. So the number of possible positive numbers is 4, because that's the maximum number we can have, because we have 4 sign changes, or any even number less than it. So we could subtract it by 2. So 2 less than 4 is, and then if we do it again, we would get, so the number of possible positive numbers is 4, 2, and 0. Any questions on this here before we do the negatives? For our negatives, we're going to find f of negative x. So we're going to replace every x with negative x. And that's what we did the first time when we encountered this. But we also noticed the fact that anytime the degree or the exponent was odd, the sign changed. Anytime the exponent was even, the sign stayed the same. So when we look at the first one, we have x to the fifth. Well, the fifth power would be odd, so the sign would change. Because it's positive 6x to the fifth, it's now going to become negative 6x to the fifth. Our next power is even, so the sign would stay the same. Since it's negative 27 to begin with, it's going to say negative 27 x to the fourth. Our next one is 53x to the third. Well, that is an odd power, so the sign would change from positive to negative. Our next one is negative 2x squared. Well, our second, or the number 2 for our exponent is even, so the sign would stay the same. So we would still have negative x squared. The next one we have is negative 36x. It would be positive, because even though it's not written, the exponent is 1, which is odd, so we would need to change the sign. And then we would have plus 40, because the constant term, the number without a variable, is not going to change because it is a constant term. Now at this point, again, we would count the number of sign changes. So from our first term to our second term, we're going negative to negative. The sign does not change. Second to third, it's still negative to negative. Our third to fourth is still negative to negative. Our fourth to fifth term does go from negative to positive, so that is 1. And our last 2 terms go from positive to positive. So the number of negatives that we can have is 1 or 2 less than it, or an even number less than it. Well, if we subtract 2 from 1, we get negative 1. We can't have a negative amount of possible number choices. So the number of possible positive is 4, 2, and 0, and the number of negatives is 1. If you put this down as your answer on the test, I will mark it wrong. Because again, our answer is given in to us as a chart. Because we have to list out the combinations of positives, negatives, and complex. Now the total possible positives that we can have is 4. Yep, 4. I was thinking of a different one. Come on. So we could have 4 is the most positives, and the most negatives we can have is 1. We start out the max with both. Now the degree is 5, so the total number of solutions we need to have is 5. If I have 4 positives and 1 negative, do I have all 5? So how many complex will we have? 0. Now the way that I go from here is we could go based off the numbers that we were given, but I really start with the negatives and subtract 2 if I can. Well, at 1, can we subtract 2 from it? No. So I would keep doing the subtractions for the negatives until I can't anymore. And once I hit that point, I will reset the negatives back to their max, which here would be 1, and I will subtract the positives by amount of 2. So that would go from 4 to 2. And then I'll do the same thing with negatives. I will keep subtracting 2 till I can't anymore. And once I hit that point, I'll reset it back to the max, which is, well, still 1, and then bump the positives down a set of 2 and hit all the negatives again. Now looking at this one here, well, we have 2 positive, 1 negative, which gives me a total of, how many am I missing? So there will be 2 complex. Then I would go through and subtract 2 again from negatives, but here we can't, because that's as far as we got, so I'll subtract 2 from the positives, which gives me 0, 1 negative, and 4 complex. Now I can't subtract any from the negatives, and I can't subtract any more from the positive, so this is it. So this here would be our answer. Now these here will be our answers. In the complex, the number of complex solutions in any one of those spots will always be an even number. Because for any complex numbers, if A plus B is a solution, then A minus BI is a solution also. They always come in pairs. So if we look at this here and count the number of sign changes from just our given function, from x to the 7th to x to the 5th, we do have 1. X to the 5th to x to the 4th, we do have 2. From our 4th to the 3rd, we would have a third one because it's changing sign. From x cubed to x squared, we don't because the sign stayed the same. X cubed to x, we would have our 4th because the signs do change. And from x to our constant term, we would have 5. So the number of possible positive solutions is 5, 3, and 1. Because 5 would be the max, and then we can subtract 2 to get 3, and then subtract 2 to get 1, at which point we can't subtract anymore. Now for the negative equation, when we plug in negative x, any exponent that's an odd number, the sign's going to change from positive to negative, or negative to positive. In any power that's even, the sign's going to stay the same. So if we applied that here, we would get negative 6x to the 7th, plus 5x to the 5th, plus 27x to the 4th, plus 30x cubed, minus 20x squared, minus 5x, minus 6. And I know I jumped through there, but pretty much if the exponent was odd, we switched the sign. If it's even, the sign stayed the same. Now at this point here, we can count the number of sign changes. Well, we would have 1. Our second set would not. Our third would not. Our fourth would. And then that is going to be it. Bless you. So the number of negatives is going to be 2 or 0. Because there's only 2 places in the negative case where the sign did change from positive to negative or negative to positive, going from term to term. Any questions on how we found these numbers for positive and negative? Now we can set up our table. Positive, negative, complex. So the most positives that we could have is, and the most negatives we can have is 2. Now the degree is 7, and 5 and 2 would give us 7. So there would be 0 complex. Now I'm going to start decreasing the negatives till I can't anymore and keeping the number of positives the same. Because we can still have 5 positives, but if I subtract 2 from 2, I get 0. So we could have 5 positives, 0 negatives, and 2 complex. Well, can we subtract 2 again for the negatives? Well, no, because it would become a negative number. So I reset the negatives back to 2, but this time I decreased the positives by 2. Since I can't subtract any more from the negatives, I reset it and decrease the positives by 1 amount of 2. and we go again. Well, if I have 3 positives and 2 negatives, I'm missing 2. Okay, let's start decreasing the negatives again. I can decrease the negatives by a factor of 2, which takes us from 2 to 0. So if I have 3 positives and 0 negatives, I have 4 complex. Now I can't decrease the negatives anymore, so I put it back to its maximum of 2 and decrease the positives again, which gives us 1. Now if I have 1 positives and 2 negatives, I have 4 complex. And lastly, we will decrease the negatives one more time, which would give me how many complex? 6. Now at this point, I can't decrease the positives or negatives any further, so this here is the solution, is this chart here. So we wanted to list it as a chart, not just that the positives are 5, 3, and 1, and the negatives are 2 and 0. Any other questions on this here? All right. Any questions on 29 through 34, or one of those that you want to look at in particular? Okay. So 29 is the one we wanted to look at, yes? So degree is 5, so we know that it's going to have 5 solutions. If we graph it and it gave us 5 solutions, we are finished. But we need at least 3. And the way that we can get at this is using the graphing calculator. So what we can do is we can hit y equals and type the function in, which has already been done. Because once we type the function in for y equals, we can hit graph. And we're looking for where it crosses the x-axis, because we're trying to find out what value of x is going to make the y value equal 0. So we do have these 3 locations. Now if we go second graph, well, we can see at -5, 1, and 4, the y value is 0. Whenever x is 0 is just where it crosses the y-intercept. We don't really care much for the y-intercept if we're trying to solve. But we do see when x is -5, 1, and 4, it does make the equation equal 0, which we're actually looking for. So what that tells us so far, x is equal to -5, 1, and 8. So the calculator told us that these 3 are the solutions, and that's as many as we need, because with these 3 solutions, I can take this from a degree 5 down to a degree 2 using synthetic division. So we'll set up our synthetic division with our cubbyhole and line. Now the numbers going across the top will be the coefficients. So we would have 1 for x to the 5th and then 0, because we don't have an x to the 4th term, we need to fill it in with 0. Whenever there's a missing variable, we have to fill it in with 0. Then we would have -20 for x cubed, 20 for x squared, -21 for x, and 20. Any questions on how we set this up? Yes, sir. Okay, that's fine. Now, it doesn't matter which one of these plug in first. We can pick any of them. So we can pick -5 first. And then we're going to do our multiplication. We're going to do -5 times 1 is -5. Then we would add straight down. 0 plus -5 is -5. -5 times -5 is going to be positive 25. Because the negative times a negative would make a positive. -20 plus 25 is going to give us 5. -5 times 5 is going to give us -25. And 20 plus -25 will be -5. -5 times -5 is going to give us positive 25. -21 plus 25 is 4. And negative 5 times positive 4 is going to give us negative 20. And 20 plus negative 20 would give us 0. Okay. So now we needed to go it again with, so we'll do 1. Now 1 times 1 gives us negative 5 plus 1 is 1 times negative 4 is negative 4. 5 plus negative 4 is 1 times 1 is negative 5 plus 1 is, and 1 times negative 4 is, which gives us 0. Now we need to do it for 4. Bring down the 1. Now 4 times 1 is going to give us 4. Negative 4 plus 4 is 4 times 0 is 0. 1 plus 0 is 1. 4 times 1 is 4, and negative 4 plus 4 is 0. Okay. Now what that leaves us with, if we plug the variables back in, let's go on and finish this here. The remainder would be 0. 1 would be our constant term. 0 would be the term with x, and 1 would be the term with x squared. So what that tells us is that we have x squared plus 1 is equal to 0. Now because we don't have a middle term, we can use the square root method by subtracting 1 from both sides first, telling me that x squared is equal to negative 1. At which point we can square root both sides, telling me that x is equal to plus or minus the square root of negative 1, which is I, because the square root of negative 1 is I. And then we also have negative 5, 1, and 4. And those would be our solutions. Now, there will be a few, but almost all of them will get you down to at least a quadratic, if not lower. All right, guys, so your test is tomorrow.